Example number 1. The decreasing order of atomic radius of fluorine, nitrogen and oxygen is oxygen greater than fluorine greater than nitrogen. They've given two statements. Among them, we have to choose the right option. In order to understand about the atomic radius, one must consider the effective nuclear charge and the repulsion between the electrons. In order to understand about the nuclear charge, we must know how many protons are there. Nitrogen, oxygen and fluorine. Atomic number is 7, 8 and 9 respectively. Therefore, in case of nitrogen, you have 7 nuclear charge, that is 7 protons, 8 for oxygen and 9 for fluorine. This is the electronic configuration and the electronic arrangement. Actually, if you consider across the period means nitrogen, oxygen, and fluorine, atomic radius should decrease. The general trend is the atomic radius should decrease because the electrons are added to the same shell and also the effective nuclear charge increases across the period. When the effective nuclear charge increases, the attraction between the valence electrons and the nucleus are getting increased. So this is a general trend. But one more interesting factor here is nitrogen, oxygen and fluorine belongs to the second period of the periodic table. It belongs to the second period. That's nothing but group 15, 16 and 17. We know that this belongs to group 15 nitrogen. Nitrogen is group 15. This is group 16 and this is group 17. Group 17. The second period element shows anomalous behavior. We have studied that it shows anomalous behavior. That means their properties are slightly different. Whatever the trend which we expect, so it will be slightly deviate from it. Now, how nitrogen is least they are saying. Look at the electronic configuration. In the first case, nitrogen is half filled. Each orbital is singly filled, which is more stable. If you consider oxygen, there are two unpaired electrons are there. One electron is getting paired up. In one of the orbital, you can see a pair of electron. So this is the paired one. Paired one. Similarly, if I consider oxygen, there are two pairing up of the electrons. The two electrons which are paired up. Now, why are we considering the pairing up of the electron? When there is a pairing between the electrons, repulsion will be more. That is known as inter-electronic repulsion. Inter-electronic repulsion. If that is the case, we expect more repulsion for fluorine first, then second one is for oxygen, and the least one is for nitrogen. Since in case of nitrogen there is a least repulsion, it has more atomic radius. So compared to these two, oxygen and fluorine, definitely nitrogen atomic radius is more because nitrogen atomic radius is less because of less repulsion. When there is less repulsion, definitely the attraction between the electrons and the the nucleus goes on increases, due to which it has less. Now, how to choose between oxygen and fluorine? Between oxygen and fluorine, the effective nuclear charge is more for fluorine. Effective nuclear charge is more for fluorine. And the repulsion is compensated with whatever the repulsion of electron is there due to the pairing up of the electron, that is compensated with the nuclear charge. Due to which the second less atomic radius is for fluorine. Therefore, oxygen will be highest. Why oxygen will be highest? Because it's a small size atom. There is one electron which is getting paired up. There is a repulsion between the electron. When the repulsion between the electron is there, the orbitals are slightly getting expanded. When the orbitals are getting expanded, definitely atomic radius increases. Therefore, highest is for oxygen, next for fluorine, then least for nitrogen. In case of oxygen, the effect of effective nuclear charge is not dominant. Not dominant. So in case of fluorine, definitely it is dominant, but in case of oxygen, which is not dominant, due to which oxygen has highest atomic radius, then comes fluorine, then it is nitrogen. Therefore, the first statement is correct. The first statement is correct. Now, the second statement. The second statement, the decreasing order of van der Waals radius, nitrogen, oxygen, hydrogen, chlorine, bromine. See, van der Waals radius is between two nonpolar molecules. And the van der Waals radius increases with increase in size or the mass of the given element. Now, among all of them, bromine will be having highest mass. Therefore, this will have larger van der Waals radius. Therefore, bromine is the highest. Then second one is for chlorine. Second highest mass is for chlorine. Now, we have to choose between nitrogen and oxygen. If I consider just the mass or the size, definitely it's more for oxygen than it should be for nitrogen. But what we are trying to understand here is, in case of oxygen, in case of van der Waals radius, the nuclear charge dominates. When the nuclear charge is dominating, definitely the size decreases, due to which nitrogen has more, then comes oxygen, hydrogen will be for least. Therefore, it is option 2, which is also right. The correct options are option A, 1 and 2. That's the correct option. Between nitrogen and oxygen, oxygen has oxygen has less atomic radius, because atomic we are not talking about in terms of atomic radius, in terms of van der Waals radius. So definitely it will be less, because the effective nuclear charge increases in case of oxygen, due to which the van der Waals radius will be more. The correct option is A.